Aim of this experiment is to study the effect of adrenaline on frog's heart. Objectives of this experiment are to record and understand mechanical activity of heart, to understand chronotropic and inotropic effects, to understand mechanism of action of adrenaline on heart, to understand the terms tachycardia and bradycardia.
The requirement for this experiment is that animal we need frog, physiological solution frog ringer solution, drug adrenaline stock solution 10 microgram per ml, instruments we need Sherrington's rotating drum, Sterling's heart lever, modified Sims venous cannula, perfusion bottle and tube, dissecting tray, surgical instrument, disposable insulin syringe.
Adrenaline and noradrenaline act as neurotransmitters at sympathetic sites and in some areas of brain. Adrenaline, like sympathomimetics, increase heart rate by activating SA node or pacemaker.
So this is the normal heart activity and this is the graph for the action potential in case of normal heart. When we inject adrenaline, here it is the graph of action potentials. So adrenaline increase the heart rate by activating the SA node or pacemaker. Okay, so you have to see here, this is the SA node. So the activity of this SA node get increases.
Both adrenaline and noradrenaline also activate latent pacemakers, that is AV node, Purkinje's fibers. Force of cardiac contraction is also increased due to adrenaline. Adrenaline act on both alpha and beta adrenoreceptors. Heart is innervated by beta adrenoreceptor to which adrenaline interacts and influences change in permeability for calcium ions and sodium ions. This change in permeability leads to excitatory effect on heart muscle and increase in rate and force of contraction of heart.
So here it is when we inject the adrenaline, the beta-1 receptor which is present on the heart. So the adrenaline bind that beta-1 receptor and thereby they causes the increase into the heart rate and force of contraction of heart. Due to the increase into the positive charge inside the intracellular region. So calcium ions and sodium ion concentrated get increases at these intracellular regions and thereby force of contraction and heart rate get increases due to the adrenaline. Here it is the procedure of experiment.
For studying the effect of adrenaline on frog's heart, perfuse isolated and mounted frog's heart with frog ringer solution. Now start the drum and record normal contractions of heart on smoked paper for 1 minute. In these pressings, the number of beats per minute indicates rate of contraction of heart, whereas height of a single beat indicates force of contraction. You can see that all the pegs in the tracings are of same height and at same distance. This means contractions are rhythmic and with normal tone. Stop the drum, inject 0.1 ml of adrenaline solution in the cannula, Start the drum immediately and record the response of heart on the smoked pepper for 1 minute. You can see that the rate of contraction and force of contraction of heart increases due to adrenaline. Also observe rhythmicity and tone of contraction. Repeat the same procedure by injecting 0.2, 0.3 and 0.4 ml of adrenaline. Allow a time gap of 5 minutes between two successive doses to wear off the effect of earlier dose. From these observations, we can say that adrenaline has positive chronotropic and positive inotropic effect on heart. Thus, adrenergic drugs find application in bradycardia and as cardiac stimulants.
As you see this procedure, you have observed that this adrenaline drugs which causes increase into the heart rate and force of contraction. So it possesses the positive chronotropic and positive inotropic effect on heart. Okay, so this chronotropic effect related with heart rate and inotropic effect it relates with force of contraction. So it possesses the positive effect on both chronotropic and inotropic effect. So that's why it increases the heart rate and force of contraction by acting on beta 1 receptor which is present on the heart, and therefore these adrenergic drugs find their application in bradycardia like conditions. Okay, so what happen in bradycardia? There will be a decrease into the heart rate and force of contraction, right? So that's why this adrenaline having their benefits or their applications in case of bradycardia condition in which this adrenaline drug increases the heart rate and force of contraction. So here it is the observation table for study the effect of adrenaline on frog's heart. Okay, so this is the 0.1 ml dose when we injected. So here it is the graph that shows the time versus force of contraction. Right, so 0.1 dose that exerted the effect, that is the heart rate and force of contraction get increases as we compare with the normal heart rate, right? So this is the graph for 0.2 ml adrenaline dose. So there will be a increase into the height of these peaks. Okay, as the dose increases, the peak height get increases gradually. So here you observe this is the graph for 0.3 ml dose of adrenaline, and this is the graph for 0.4 ml dose of adrenaline. So by observation we can easily predict that adrenaline having their effect on the heart rate and force of contraction.
Adrenaline stimulates heart functioning by increasing its rate and force of contraction. Adrenaline acts as cardiac stimulant.
Okay, so these adrenaline drugs which stimulates the heart by increasing their heart rate and force of contraction, and therefore this adrenaline drug act as an cardiac stimulant. Okay. So here it is, this experiment is get finished. So according this observation table, we can easily conclude that from the observation, it is concluded that adrenaline causes increase in heart rate, increase in force of contraction, and increase in the tone of heart. Okay, so here it is, this experiment is get finished. So thank you.